So, hello everyone. Um, a warm welcome to the session. I'll quickly introduce myself and then we'll get started. Let me share my profile on LinkedIn. That's me. My name is Bharani Kumar Depuru. I happen to be Industrial Revolution 4.0 implementer, a chief data scientist on 4 different companies. One of the companies is a US-based company. One another is a Malaysian company. And we have 2 other companies which are Indian based. Alongside that, I also do consulting for various other companies in my own personal capacity. And director of one company can serve on the board of a few other companies, and that's called as interlocking director role. And I play that role quite often with quite a few companies, which I did not mention here in my profile. I hold a master's degree from IIT, and I also hold a master's degree from Indian School of Business. That's in short about my profile. And one more last thing is, over the last 16 years, I worked with companies such as HSBC, Indian Tobacco Corporation, Infotech, ITC Infotech. I worked with Infosys, and the last company with which I was employed as an employee was with Deloitte. Post that, we formed a company, and we formed 2 companies rather. One is InnoDataTix, which operates in the space of advanced analytics. And we also have a company in the space of education. We call it as EdTech company, and that is 360 Digit MG. Once again, welcome to the session. Sit back, enjoy, relax, and you will understand all the concepts. Another word of caution is that throughout the training, I would be tempted to use some kind of witty examples. Okay. I do not intend to hurt anyone's sentiments. Okay. I might use sometimes, some jovial anecdotes, some jovial examples pertaining to some genders, but then I don't intend to hurt anyone's feelings. This is a very dry concept. A lot of subjects, a lot of topics would be very dry. So I just want to bring in that tinge of humor to ensure that you all feel that the session is lively and you actually start grasping the concepts. Okay, so let's get started. Welcome to the data science training program. This is one of the very comprehensive programs that we have come up with. And we are going to explain you all about project management methodology first. Because we believe that once you have a 30,000 feet view of how the projects are handled in real world, in real time, you will be able to understand the finer nuances, the finer concepts within each and every module. So with that hope, we will get started with the agenda. We will discuss about stages of data analytics. We will understand about CRISP MLQ, which is a project management methodology. We will look into the business understanding aspect of it. Okay, so here are a few stages of analytics. The first thing is called as descriptive analytics. In descriptive analytics, you answer questions on what happened in the past. Obviously, when we talk about analytics, data science or data analytics or machine learning or deep learning or artificial intelligence, etc., we deal with historical data. We deal with the past data. So you would certainly need to have access to the past data. And say you had, or you have a database rather, which has details of, all the countries, number of COVID-19 cases, that have emerged in all the countries, how many people have recovered, how many people succumbed, how many people are now inoculated, vaccinated. Say you have all that data. I'm talking about historical data. Say you have access to all this historical data. If you take that data, and then if you try to answer questions on what happened, meaning, did the number of COVID-19 cases increase? Or did the number of COVID-19 cases first increase and then did it decrease because of lockdown, and did it once again increase? What happened? And because of vaccination, did the number of COVID-19 cases drop significantly? You would understand the trend. You would understand the patterns. You will understand the key inflection points. Inflection points means sudden change in the patterns, are called as inflection points. You would understand what happened. Once you answer the questions surrounding what happened in the past until now. So you're taking the historical data until now, and then you're trying to analyze what happened until now. Until now, what was the trend pertaining to number of COVID-19 cases? What is the trend pertaining to number of people who have recovered? What is the trend pertaining to the number of people who are inoculated or vaccinated? Right? If you answer these kind of questions, then that would be called as descriptive analytics. Next stage of analytics would be diagnostic analytics. As part of diagnostic analytics, you ask questions on why something happened. Why is it that there is a sudden increase in the number of COVID-19 cases? Why? What happened? Why is it that there is a sudden drop in the number of COVID-19 cases? Why is it that there is again increase in the COVID-19 cases? Why is it that there is again a drop? Why? Right? Because of probably lockdown, because of people, again, it shot up, the number of cases shot up because people were pretty relaxed. And then again, the number of cases have come down thanks to vaccination, whatever, right? So you tag a reason on why something has happened. Okay, that is called as diagnostic analytics. Next, you have predictive analytics. At this juncture, you ask questions on what might happen in the future. You have the data until now, and then you take this data and forecast or predict on how many COVID-19 cases we might have in the future. How many COVID-19 patients might recover. What proportion of the population might get inoculated or vaccinated in the next 1 year, or in the next 3 months, or in the next 3 weeks, or in the next 3 days, whatever be the time horizon, you try to forecast or predict. You can predict for the next 10 years also, but the question that you need to ask is, would that prediction be valid? Because many things are changing. Suddenly you have war. Suddenly you have someone visiting Taiwan, and then suddenly things are changing, right? So you need to be cognizant. You need to use your own intelligence and understand on for how many days or weeks or months or quarters or years do you want to predict based on your visibility. Okay, and that is called as predictive analytics. So predictive analytics talks about future, what might happen in the future. Then we have the final stage that one can attain, that is called as prescriptive analytics. So as part of your prediction, say you understood that the number of COVID-19 cases would probably once again grow in the next 3 months. Based on that, you take some decision. and you play around with scenarios called as what if scenarios. This is also called as what if analysis. Okay, for the next 3 months, my prediction says that the number of COVID-19 cases would increase. What can I do in my capacity? Can I increase the number of vaccines? Can I give away the vaccines for free? Or should I increase the number of hospitals? Or should I conduct a lot of awareness campaigns that people need to wear masks, they need to wash their hands, they need to use hand sanitizers? Do I need to go on a big bang, communication strategy to ensure that, people are well aware of what are the do's and don'ts to ensure that the COVID-19 cases are in control? Okay, if you do all of that, that is called as prescriptive analytics. So you're trying to explore the various options that you have based on your predictions. So based on your predictions, you try to figure out what is good, what is bad, what might happen, etc. At this point of time, I wish to give you another example, rather a real-time example, right? And even before that, if you go to our YouTube channel, you'll find that during COVID, we have worked along with a hospital called as Apollo Hospital, which is Indian-based, obviously. And we have built forecasting models to forecast the number of COVID-19 cases. And that is when the Indian government told that, you know what, people should refrain from doing any predictions, etc., because that might create panic in the society. So that is when we backed off. But that specific project that we have done was well taken by the South Korean scientists also. They've also looked at the model that we built and they told, good, it's very unique in its own, is what they have endorsed, right? They actually endorsed that particular project that we have worked upon. And there is yet another example that I want to give from prescriptive analytics standpoint. We keep doing a lot of advanced analytics consulting work for various customers across the globe. And this specific client for whom we have done the project is one of the giants in the space of food and beverages. I'm talking about a food and beverages company, which is a gold standard company. I mean, without naming that, a few of y'all who are intelligent would have guessed it by now. Anyways, there within that, we had something called as preforms. I'm going to now explain you all the entire value chain of specific beverages company. They had something called as preform. Preform is a raw material which is used to manufacture PET bottles. You would have consumed Coke, Thumbs Up, Sprite, Fanta, whatever, right? Soft drinks. And those soft drinks are available for us in various quantities: 250 ml, 200 ml, 500 ml, 1 liter, 1.5 liters, 2 liters, so on and so forth. So these preforms go into a sensor or a unit called as blower unit. Okay, there was something called as a blower unit. In this blower unit, air was blown into the preform. It's like a glass material, okay? And air is blown into that. If you blow less air with less pressure, it would probably become a 200 ml bottle. If you gush in more air with more pressure, it would probably become a 1 liter bottle. Okay, that's the blower unit. Within the blower unit, there was a sensor called as pressure sensor. which would monitor air pressure, the amount of air which is being blown, what is the pressure at which the air is being blown into the preform, which is a raw material. Okay. And then once the air is blown, once you get the bottles, you need to pour syrup into that, right? So there was a specific unit called as chiller unit. Chiller unit. In the chiller unit, the syrup, I mean, when you try, consuming Coke or Pepsi, there'll be some tinge, some taste. That taste is maintained thanks to the chiller unit. Chiller unit will maintain the syrup at a specific temperature. If the temperature is not maintained properly, appropriately, then you would not get the taste. Every year, gallons and gallons of syrup is put under the drain. Okay, it goes into the drain because of the temperature fluctuations. So there was a sensor called as temperature sensor. This temperature sensor was capturing temperature on an ongoing basis. Then, when you fill the water into the bottle, let me take this as an example if you are able to see me. So, suppose that this is the soft drink bottle. Okay. And if you pour the water or the syrup until the brim, that is until the top here, until the brim, then the moment you open the lid, entire, the carbonated water would gush out. So customers would be unhappy. At the same time, if the syrup is filled only until here, the liquid that is poured into the bottle, the beverage, if it's only filled until here, you as a customer would be dissatisfied. Okay. The reason being, you might feel that you are cheated. For the money that you're paying, you're not getting sufficient quantity. Okay. To address this issue, there was a specific unit called as packaging unit. In this packaging unit, there were height sensors, which will measure the height up to which the syrup is filled. If the syrup is filled until the brim, it will reject that lot. If the syrup is filled to a lower quantity, still it is pushed away. All these projects, etc., are there on my LinkedIn profile. If you go there, you will be able to explore those further, right? I've also placed certain videos for your consumption. So there was height sensor. Then packaging unit, they used to put a cover, a sticker, promote something on that. If it is, say, a World Cup match, or if it's a World Cup season, rather, they would put a sticker pertaining to World Cup, etc. And then it would go into the pallets, big boxes. From there into the trucks, from trucks to the distributors, distributors to the retailers, from there to us consumers, right? This is the usual. But the point that we need to remember is that we started collecting the data from all these sensors. Okay, from all these sensors, we started capturing the data, and then we have built a prediction model to predict whether a specific sensor would fail or not. Okay. And if you predict that, you know what, this blower unit might fail in the next 1 hour, if that is your prediction that in the next 1 hour, blower unit might fail, then you might want to take an action to automatically shut down the blower unit. You might want to automatically shut down the blower unit. Or if the prediction says that Do you know what? Your chiller unit might fail in the next 2 hours. You might want to stop the chiller unit automatically, because otherwise it might get damaged beyond a point, right? So taking such actions based on your predictions is called as prescriptive analytics. Now, this is called as stages of analytics. And the first stage is descriptive analytics. Second stage is diagnostic analytics. The third stage is predictive analytics. And finally, we have prescriptive analytics. Hope you have had a clear understanding on this. Now, we will get into the next discussion, which is the data types part of it. Even before that, even before getting into the discussion, we will talk about the project management methodology called as CRISP MLQ. So even before I go there, I think we have a question. Yeah, Priyanka.
So in the predictive analytics part, where you were taking the temperature sensors and pressure sensors into consideration, of course, in order for us to be able to predict, there would be an upper limit and a lower limit of data, right?
What do you mean by upper limit and lower limit of data?
I mean, we have to have certain pre-data, I mean, certain data in advance.
Whatever data is coming from the sensors, you're taking
Mhm.
that data.
Okay, and we deduce the data based on all of the data that we have collected so far.
Is your question on how do you build a model? Is that your question?
Uh, Sort of, almost.
We'll get there.
All right.
Okay. दिल्ली
Yeah.
अभी काफी दूर है. We'll get there. Okay.
Okay.
Yeah. Yeah. This is a very high level overview. Slowly and steadily, we will get to the various discussions. Okay. So let's get into the next discussion. Here we are going to now talk about CRISP MLQ, which is a project management methodology in handling any of your data related projects. This specific framework is extremely famous, and CRISP MLQ has 6 phases: business and data understanding, data preparation, model building and tuning, evaluation, model deployment, monitoring and maintenance. We are going to delve into each and every phase, and we are going to talk about all these phases in a lot detail. And CRISP MLQ stands for cross industry. The CR in CRISP stands for cross. I stands for industry here. S stands for standard. P stands for process. ML stands for machine learning. And then Q stands for quality assurance. That is what CRISP MLQ stands for. And these are the 6 phases: business and data understanding, data preparation, model building, evaluation, deployment, monitoring and maintenance. And these phases go on and on and on. Do not assume that data science projects are one-time implementations, not really. Data science projects go on and on, right? You keep implementing that on an ongoing basis. So now, while at a high level, we understand that CRISP MLQ has 6 phases, we also need to understand each and every phase in finer detail. Okay. At least to get started, we'll get a high level overview, a 30,000 feet view on what's happening with this specific framework or a methodology, and how this methodology helps you in a structured manner, step by step, move towards successful implementation of the projects. So let's get started. So here we are going to talk about CRISP MLQ, and we are going to talk about business understanding. And as part of business understanding, we have to first understand and define the scope of the project. As part of this, you need to understand the business problem. And once you understand the business problem, you need to record the business objectives, and then you need to record the business constraints. So let us get into this and try to understand the first problem. Suppose head of loan department, head of loan department of a bank. Okay, let me say HSBC Bank, just for the ease of understanding, walks up to you and says that, hey, my dear data scientist, now that you got trained on data science, can you help me solve this problem? Obviously, you'll ask, hey, what is that problem that I can solve, Mr. Head of Loan Department? And this guy might say that, do you know what? Significant proportion of customers who take loan are unable to repay. Say there is a person who says that I want loan for, $10,000. And the loan got approved. And every month, bank might say that, do you know what? I expect you to pay me probably $100 every month. And then the person who took the loan, probably he paid for first month, second month, third month, and then fourth month, he did not pay, fifth month, sixth month, so on and so forth. The person stopped repaying. If the person does not pay for 3 months, 3 consecutive months, then this loan, which was issued to a customer, would be called as NPA, non-performing asset. Okay, and this customer would be from there on called as a defaulter. Defaulter means person who did not pay the loan. He took the loan from the bank, but he did not repay. For 3 installments, it could be monthly installments or quarterly installments or half-yearly installments, whatever is the tenure or the duration of paying the installments. If they do not pay 3 consecutive installments, then that loan would be called as NPA, non-performing assets. And every bank has a KPI, key performance indicator. Okay, and one of the key performance indicators is how much is your NPA? They say that, do you know what? NPA, percentage of loans which become non-performing assets, should always be less than probably 2% or less than 1%. So different banks have different norms. And the health of the bank, the success of the bank is measured using one of the KPIs, which is this. And hence, The head of loan department would like to take your service now that you're data scientists, right? The head of loan department wants to take your service and get this issue fixed. And friends, throughout, when I give you examples, please bear in mind that all these are real-time examples. I would also like to bring in certain business aspects so that you all understand why we are actually, resorting to data science to solve these. So understand the business aspects, also the real-time use cases. These are all the real-time projects that I've personally worked upon. So just try to absorb, okay, the business aspects of it as well. This is one way to gain domain knowledge, which is pivotal for any data scientist. Okay. So now that you understood the business problem from the head of loan department, you would be recording business objectives. You should rather record the business objective. The number of people who are not repaying is significant. So you want to minimize the loan defaulters. You want to minimize the number of loan defaulters. That is going to be your objective. You can have a single objective or you can have multiple objectives. Okay. How many objectives do you want to address? It depends on you. Problem is given to you by the client of HSBC. HSBC, if that is your client, then the head of loan department has thrown a business problem at you, and it's up to you on how you want to solve that. What all do you want to solve, right? But given this business problem, I believe we need to minimize the number of loan defaulters. And this happens to be a objective. Now here, what should we do? Okay. Usually what happens is when you're expected to solve or achieve this kind of business objective, then you go and collect the historical data from the bank. You'll say, okay, my dear head of loan department, I need access to data. Loan department head might say, okay, what data do you need? So you might say that, you know what, I want the information on how many customers have applied for the loan in the past. Okay, head of loan department might say that, you know what, 10,000 customers have applied for the loan until now. Okay. Do you know how many of them have repaid the complete loan? And how many of them have defaulted on the loan? That means did not repay the loan for 3 consecutive months. Do you have that information? Yep, sure, any bank would have that. So they would give you data on how many people have defaulted, how many people have not defaulted, not default. In that way, say you have data. And you might also say, hey, I also want to know what is the age of those customers? What is the gender? What was the loan category? How much was the loan amount which was disbursed? What was the loan interest amount? Okay, so on and so forth. Say you want to capture all that data. Not capture, you want access to all this data. This variable, which is talking about whether a customer has defaulted in the past or not, is usually represented using Y, because that is an outcome you are really interested in, right? And that is called as output variable. It's given a notation Y usually, and that is called as output variable. And age, gender, income, educational qualification, loan amount, loan category, interest amount, all of these are called as inputs. They're all called as inputs. They're represented using X, X1, X2, X3, X4, so on and so forth. These are all your inputs. So given the bunch of inputs, a few customers have defaulted. Given the bunch of inputs, a few customers have not defaulted. Now, when you supply this data to your machine learning algorithm, I'll call it as ML algo. When you supply this data to your machine learning algorithm, it would learn the patterns. It would learn the trends in between your Y and X's. It will try to learn the patterns between your output variable and your input variables. Okay, it's like machine learning. It will learn the patterns. If the age is 32, gender female, education graduation, loan category was probably educational loan. Loan amount was probably $5,000. Loan interest was 4%, so on and so forth. Given these inputs, people of this kind might default. If the output variable has default, then people of this kind might default. Age 36, female, postgraduate, so on and so forth. Loan amount, loan category, loan amount, interest amount. Given all the data, probably this customer did not default, So given these kind of inputs, output is not default. So your machine learning algorithm would learn the patterns, and it is going to remember those patterns. And eventually, when you have a new customer who walks in and applies for a loan, you collect all these details. What is the age, gender, income, loan category, loan amount, so on and so forth. You take all of these inputs and you supply these inputs to the machine learning algorithm that you've built. And what would then happen is your machine learning algorithm will spill out the predictions. It would give you the predictions. Okay. And your machine learning algorithm might say, in this case, for example, if the prediction says that there's 90% chance that customers of this kind, that means customers of this age, this gender, this educational qualification, this loan amount, this loan category, so on and so forth, there's 90% chance that customers of this kind might default. Given this prediction, which is coming out from your machine learning algorithm, what would we do? Would you approve the loan or would you reject the loan? Sure, you would reject the loan. Any rational thinking person would say, hey, let me reject the loan. Because it's 90% chance that this person would take the money and run away. If there's such a high chance that someone might default on the loan, then you would rather reject the loan. However, the HSBC guy, remember, who has given you this business problem, would that customer be happy? Would that stakeholder be happy? The head of loan department? Not really. The reason being, how do banks make profits? What do banks do? They issue loan to the customers. And what do customers do? They repay to the bank interest amount and principal amount. Okay. I call it as loan amount. And banks would then make profits based on the interest amount. Based on the interest amount that you pay to the bank, banks are going to pay the loan, not loans. Yeah, sure. They will also have to pay loans because they take it from the federal government, federal banks, right? Reserve Bank of India, etc. And then um, when they take the loan from government, they have to repay. So from the interest amount that they get, they pay some interest amount to the government or to Reserve Bank of India or some federal bank. And then the remaining amount they are going to use to pay the salaries of the bank employees, rents, and various other operational expenses. If they do not even lend a loan, because your prediction model is saying that for this customer, there's 90% chance that the customer would default. Hence, you're rejecting. By rejecting, you're not even lending the loan. If you do not lend a loan, where will you get the interest amount from? How will you survive as a bank? Right? Hence, we as data scientists should not stop here. There is something else that we need to perform. And that something else is we do something called as survival analytics. This survival analytics is a term which has emerged from medical field, medical industry. For how long would a patient survive if that patient is diagnosed with cancer? Okay. Anyways, so here you would get to know additional information that people of this kind, if this customer is applying for the loan, it would also predict that means survival analytics will also help you predict that people of this kind will default. There is 90% chance that people of this kind will default. However, they might default, say, after 24 months or 28 months. That means if it is every month installment, customers of this kind would repay the loan, continue repaying the loan until 28 months, and then they will stop paying, and then they will default. So you need to now start thinking, hey, there is 90% chance that this customer might default. If I simply reject, that means if I do not even lend the loan, then the banks would not get the interest amount and they could not, they might not be in a position to survive. Hence, you came up with an additional algorithm, which is called a survival analytics. And why did you come up with survival analytics? Because be rest assured that this head of loan department from HSBC would tell you that good, that you're minimizing the loan defaulters by building prediction models, which then predicts that there is 90% chance or 80% chance, whatever percentage chance of someone defaulting. Based on that, I'll either approve the loan or reject the loan. Good that you have built the system. However, I want you to also help me maximize my profits. Okay, this head of loan department, no doubt, would acknowledge your work that you have done, would say that great job done. You built a prediction model which will help me take informed decisions. However, while you're trying to minimize the loan defaulters, I also would like you to maximize the profits. And that is called as business constraint. No one will give you infinite money. No one will give you infinite resources to accomplish your project. They will always put constraints on you. Given these constraints, you are expected to solve the problem. If it is just business objective and if you're asked to solve the problem, any person with basic common sense would solve. But the moment business constraints are levied, it becomes a very analytical problem to solve. You need to think through, you need to think a lot. And because of this constraint, you have started looking at something called as survival analytics. And say survival analytics says that people of this kind will default after 28 months. Then what should you do? You would probably say that, okay, let me do one thing. Let me approve the loan. Though there is 90% chance, let me approve the loan, but I am going to reduce the loan tenure to 24 months. And maybe the amount of money that you're going to disburse, approve as a loan, maybe you're going to reduce that also. So we have to start thinking from business standpoint. Remember one thing, friends, as a data scientist, what are you trying to solve? You're trying to solve a business problem. Okay, just remember that. Sure, we are going to look at a lot of examples pertaining to this so that we get a better handle. But remember one thing, you can have multiple objectives and you can have multiple constraints. Okay. Now let me give you one example, real world example only, with respect to maybe hair treatment. Okay. Say a woman goes to a hair treatment salon and says that, do you know what? I'm losing a lot of hair. Can you help me? That's a business problem. What would be the business objective here? If we were to focus only on one objective, there could be multiple objectives. What might be your business objective here? Maximize hair growth. Or you might want to say minimize hair fall. Either way, you can achieve your objective. You can have a single objective or you can have multiple objectives, my dear friends. As part of this, say the doctor has given you something called as minoxidil. What is minoxidil? Minoxidil is something which you see in almost all the hair treatments. If you apply that, you will supposedly have hair growth once again, supposedly. Now, you took that and say you were very happy because you regained your hair fall got controlled, and then you have started seeing a lot of additional hair growth. So you were very happy. But then you'll be only happy until there are no side effects. Okay. Until there are no side effects. So I'll just remove this name. I'll give you another name. Okay. Or let me talk about this one. So with respect to this minoxidil, the side effect is that you will see excess hair growth on all the other parts of your body. If you are a woman, would you like having excess hair growth on your cheeks? Would you like excess hair growth on the mustache region? Obviously, no. Right? You would not like to see that excess hair growth. That is a side effect of minoxidil, my dear friends. Okay, so because of this side effect, people started putting constraints, saying that while there is going to be excess hair growth, I don't want to see excess hair growth on the other body parts. So that would be a business constraint. So minimize hair growth on other body parts. And let me tell you that there's a small story to this minoxidil thing. Earlier, minoxidil was used to handle blood pressure. So it was actually used to minimize blood pressure. And then suddenly people started seeing excess hair growth, especially women were seeing excess hair growth. And after that, they started using that for hair treatments. That's the story behind minoxidil. But anyways, that all that aside, the point that I'm trying to drive is you need to first understand the business problem. And for every problem, you need to record the business objectives and constraints. When you record your business objectives and constraints, you need to record it using 2 to 3 words. To the extent possible. If you cannot, probably using 4 to 5 words. But don't let it extend beyond a sentence. Okay, it should not be paragraphs together. Objectives and constraints are for your stakeholders to quickly have a look at that and understand on what you're trying to solve. That is all that is expected from objectives and constraints. Another very, very important thing that you all have to bear in mind is defining the success criteria. One very important thing I request everyone to bear in mind always is that whenever you start donning the hat of a data scientist, bear in mind that we are going to solve a business problem. We are not here to build fancy algorithms. We are not here to run fancy stuff. We are here to solve business problems. So you need to first record the business success criteria. For this problem, you might say that, you know what, I will help the number of loan defaulters or the default rate. I would ensure that would always be less than probably 5%. Okay. Less than 5% is the business success criteria. I mean, the number of loan defaulters or the percentage of loan defaulters. Percentage of loan defaulters should be less than 5%. Okay, this is what you're trying to achieve. That's the business success criteria, which you need to record upfront. Then comes your machine learning success criteria. As part of your machine learning success criteria, you provide 2 things. Number one, what is your accuracy going to be? You can say that, you know what, I will ensure that the accuracy of the model, accuracy of machine learning algorithm that we're going to build is always going to be greater than probably 82% or some number you define upfront. B, you also need to define the success criteria pertaining to performance. You might say that, do you know what, the moment you supply bunch of inputs, bunch of variables to my model, I'm going to show you the results, the output within 1 millisecond or within 1 second. So that's performance. So performance of machine learning algorithm would be probably less than 1 second, meaning within a second, the moment you give the inputs, you would see that the prediction would happen and then you will see the result. Within 1 second, you'll see that. By reducing the number of loan defaulters by 5% to less than 5% rather, how much money are you going to save? That is called as economic success criteria. And this is what any business really, bothers about. Any business would think in this way, right? Hey, I'm, probably paying $1 million for this project to be completed. But since I'm investing $1 million, how much would I get back? That is called as return on investment. For the money that I'm investing, how much return am I getting? Okay. So you need to also define this economic success criteria as a data scientist. But for that, you can always go discuss with the business, try to understand that, as of now, how much money are you losing because of people defaulting on the loan? Say the head of loan department says that, as of now, we are losing $20 million every year per annum, every year because of loan defaulters. Then you might say that, if I were to reduce the number of loan defaulters by to less than 5%, probably it will help me save, $8 million. So you can always say that economic success criteria could be anywhere between $8 to $10 million. In that way, you can do some approximations, but you need to record these things. Think from business standpoint. If you do not have clarity, it is absolutely okay to go and check with your business people. You can check with the head of loan department of HSBC itself, and then arrive at a number which is mutually a win-win situation. There are a few more examples pertaining to business problem and defining the objectives and constraints. So let us now discuss about these also, a few additional examples as well. So let's get into that. All right. See another bank. So this time Citibank. The credit card department head walks up to you and says that, you know what? Significant proportion of customers are calling the call center and they're saying that they did not do the credit card transaction. They are getting SMS saying that, $120 deducted, but I didn't do the transaction. So what would you do? As a customer, you'll call the call center and you'll say, hey, I did not do this credit card transaction, but yet I received an SMS saying that $120 got deducted. Can you just investigate that? Is what you would say as a customer. But then if significant proportion, say 2%, 3% of overall credit card customers are calling the call center and saying that, hey, I didn't do the transaction, yet I received this SMS. Then what should we do as data scientists? We need to predict this. We need to be futuristic. Even before some fraud happens, you should be able to predict that, hey, there is fraud which might happen, right? You want to be futuristic. Given this, that you want to be futuristic, you want to detect the fraud happening, etc., you need to record the objectives. It could be a single objective or multiple objectives. And the obvious business objective would be minimize the fraud. You might want to minimize the fraud. But to minimize the fraud, we can also do this. I can say that each time you do a credit card transaction, you would receive an SMS on the mobile You'd also receive an SMS on your email. Okay. Or you'll get an automated call with an additional OTP, one-time password. You need to enter that. If I say that for every transaction, be it $1 transaction or $100 transaction, I am going to send you a one-time password as an SMS, short message service SMS, or I might want to also call you through my automated, call IVR, and then I might say that this is your OTP. For every transaction, if I keep getting calls, I'm sure the fraud would come down, but it would cause a lot of inconvenience to the customers. So what would your business say, or what will Citibank say? The head of credit card department would say, you know what? Good that you're trying to minimize fraud, but vis-a-vis, I also want you to maximize the convenience. Now it would be an interesting business problem to solve. Until now, it was child's play, walk in the park, right? If you only have business objective, trust me, it is going to be walk in the park. The moment you put a constraint, then it becomes an interesting problem to solve. Let's see a few other examples until we get a good handle on this. Say farmers are complaining. This is a use case pertaining to agriculture. Say a specific farmer comes up to you, or farmers have this generic problem. So the government walks up to you and says that, hey, your company has a bunch of data scientists. So why don't you solve this problem? The yield of crop is not improving year on year. What do I do? So what should be your objective in the first place? You have to say that, okay, my objective would be to maximize the yield, maximize the output. This should be your objective. While this is going to be your objective, you might come up with an amazing solution. You might say, do you know what? I am going to fly drones, okay, on top of the field, cultivation field. You might have acres full of, farming land. And you might say, I'm going to take a drone. To that drone, I will connect multispectral camera. You might say, I'm also going to connect, contour sensors. Contour sensors would try to find the unevenness in the surface. Because what happens is, if you have a slight slope like that, then if you sprinkle water, all that water would eventually come down, and there might be excess water here, and there might be less water here. So depending on the land surface, using contour sensors, you get this information, and then you can, ensure that you adjust the water sprinklers in such a way that there is less water which is sprinkled here, a low-lying area, because anyways, water from here would flow down and get deposited here. So you would rather not sprinkle the water here, but you would rather sprinkle more water here, maybe. So contour sensors help from that standpoint, and multispectral cameras can capture ultraviolet rays and infrared rays. These two rays are invisible to a human eye. They fall under invisible spectrum. Okay, so what we see is visible spectrum. Ultraviolet and infrared is part of invisible spectrum that can be captured using multispectral cameras. That means if you just fly it over the crop, and if you know for a fact that there are insects in this part, then you can sprinkle pesticides only on this part. You need not, sprinkle pesticides on the other healthy plants. So this is called as drone-driven technology, which is helping in precision farming. What do you mean by precision farming? When you fly your drone on top of the crop, if there are insects here, it will figure out, and it will only sprinkle pesticides in this part, and it does that automatically. Automatically, pesticides are sprinkled only in this region. That's called as precision farming. Thanks to drone-driven analytics, video analytics, image processing would help you achieve these things. But then, if you try to implement this kind of a solution, would it be cheap or would it be costly? It would be an extremely costly affair. And would the farmers be able to afford that? Not really. So what will be the constraint that will be levied on you? Minimize the cost. While you're trying to maximize the yield, if I'm not going to impose a constraint, then you will come up with probably an amazing solution, which would be extremely costly, meaning it might not be applicable for the business. The moment this constraint is levied, applied on you, that while you maximize the yield, you also need to minimize the cost, then it becomes an interesting problem, and probably you look out for cheaper ways of solving the problem. Maybe you'll go with some other drone. Maybe you'll come up with a different strategy that let me fly it, across this region, and the farmers can share the cost, whatever. So you need to think through from all those aspects. So here are a couple of examples. We will now talk about two other examples so that we get a better handle, and then we'll proceed further to the next set of concepts. But in the interest of time, I think I need to stop here, and I'll take your questions. So